So good afternoon, everyone. And this being the second session after the lunch, so I think all the risk associated with post-lunch session is now taken care of. So Senthil, it was a very interesting presentation and covered so many aspects in such a short time. And you mentioned about cybersecurity in the process. So it set up the tone for this particular session. Product launch, we had done a product launch last year, even previous year. There have been several introductions of products that have happened. This time we thought let's experiment something different. Cybersecurity on its own has a deeper manifestation. It's widely spread, and when we look at the implementation requirements, driven by the regulation, driven by technology constraints, driven by supply chain complexity, we are just heading to a very nice security concept, ultimately leading to a very low cyber assurance at the end of the development cycle. And then we are still looking at a vulnerability management and cybersecurity risks addressing throughout the life cycle. Now, that is where cybersecurity is slightly more complex in terms of the longevity and the predictive. You cannot predict the cost of security on today for lifetime. And that's where we have been thinking, we keep on scratching our heads on how can we minimize these problems. So with that, with that in mind, we came up with certain ideas, some products, and we have linked it to the compliance and the technology innovation that's happening around. And that's where I felt that this particular session, a product launch session, should not be a monologue and display of some product or features, but it should be a discussion. And that is where I would like to call upon my two colleagues, and these are industry veterans. They have been hands-on in their areas, and of course they'll introduce themselves. So first I'll call Sadashiv Bombatkere. Sadashiv has been with us Secure Things for nearly a year now already, and he comes from the Indian Navy. He started working in cybersecurity before cybersecurity was called cybersecurity. He is a President's Medal awardee for cybersecurity, implementing cybersecurity for the naval vessels from entire aspect. And the other person whom I will call upon is Dr. Asad Ansari. So Asad has been with us also for nearly a year now, and he is leading all product implementations and the cybersecurity products. He is one of those persons who, I understand that all of you probably know the famous Jeep Sherek attack. Asad was the person who gave solution for that, against that attack later on. So that's the small introduction. But I will start with a small, I will ask both of them to introduce themselves briefly. And then we will go in, and the flow is mainly a discussion, and later on we will also take some questions. In the process, if you see that there are any product launches and introductions, I'll be happy to answer that as well. So we'll start with Sadashiv's brief introduction.
Am I audible?
Yes.
Yeah, I am Sadashiv Bombatkere. My background is I did spend 35 years in the Navy, and then where I spent the bulk of my time developing cybersecurity solutions for the Navy, basically in the area of cryptographic solutions and network security solutions. After I retired, I joined Bosch, where I worked for 2 years. I set up their cybersecurity consulting and Tara group. And then I retired from there and joined Secure Things. So I've been around a long time. But my areas of interest, primarily, I'm new to the automobile industry, but the basic principles of engineering and cybersecurity effectively remain the same. And therefore, I decided to spend time in process compliance, especially ISO 21434 and 24089, which happened to come out about the time I retired very fortuitously, and also in threat analysis and risk assessment. Thank you.
Great, thank you, Sadashiv. Asad, a short introduction from your side.
Yeah, hello, I'm Asad. Good afternoon to all. I am like a total 20 years experience in automotive, mostly on vehicle cybersecurity control developments, along with the technology I mean, like a new technology, whatever coming in the market. So I will take care about those all threats and proper, like you can say, like a preventive cybersecurity solutions, so that like in futures, whatever threats we can predict and we'll give the solution in advance. Yeah, that's it. And apart from that, like I have a lot of patents and cybersecurity research, whatever like a new research and whatever like a possible for automotive cybersecurity controls. So those like I will do as my like hobbies. Yeah, thank you.
Thanks, Asad. So as you can see, what we have here is practical, hands-on CSMS compliance North Star for secure things, and the solution North Star for, again, secure things. And this is the combination that I felt will serve dual purpose. One is introduction of our products that we intend to launch today, but at the same time, look at it from the compliance perspective. I've been working in the regulatory compliance body for AIS 189-190 with the AISC, and what I understood was that the compliance is a multi-fold activity, and there are key elements that need to be considered when we start looking at implementing anything and everything to ensure regulatory compliance. So as you can see, there is going to be standards and processes. There will be a lot of innovative technology that needs to be integrated. And apart from that, there is a need for a business rationale. And because of business rationale, it also is imperative that there is a certain ecosystem that's available so that you can always have partners to rely on. There can be make or buy decisions at certain point in time. And we intend to stitch all of this together in this session through a discussion and the products that we offer. So aligning entire organization competencies to adopt the regulation implies right from the top, the CIO organization, getting the ISMS in place, moving towards the automotive side, looking at the E&D architecture, looking at the R&D that's going on for the vehicle per se, and then managing the whole life cycle for the updates as well as the cybersecurity throughout the useful life of the product. And that involves aligning competencies of various departments, various roles will emerge, various structures will emerge, could be governance, could be product security officers, program security officers, there could be supplier or partners who can enable some sort of services in terms of managed services or tools and stacks. That overall thing is kind of, there is an attempt to summarize all of that, and it's a very high level summary. But once we start getting into details, what exactly needs to be done is there is a standard to follow. So UNR 155 or AIS 189, they can be well addressed by adoption of ISO 21434. That's very well established now. And UNR 156, AIS 190 can be addressed if the provisions of ISO 24089 are adopted. So apparently CSMS, SUMS are directly linked to adoption of these two standards. So what we took was, from cybersecurity perspective, we took out all the relevant stuff, that is the clauses that make sense for cybersecurity, the actual activities that need to be done, the processes that need to be implemented. That's where Sadashiv will help us to quickly decode those. And then the technology associated with it. That's where Asad will pitch in. That is the kind of format for today's discussion. I'll take a seat and I will, then we'll have this conversation. Hope you enjoy it. So I'll start with Sadashiv. Sadashiv, so looking at the standards 21434 and 24089 adoption, from your experience of consulting for over 5 OEMs and a couple of tier ones, Indian as well as European OEMs, where do you think we start? Of course, we start from clause 5, but can you elaborate a bit on that part?
Okay, I'll just give you a brief overview. Cybersecurity is today where software development was in the mid-90s. In the mid-90s, when people developed software, it was developed more by the seat of your pants, and while there was testing and there were some processes followed. They were neither systematic nor documented. And the first standards were the mill standards, mill standard 498. It was followed by 12207, which now has become a standard, and you have different, waterfall model, agile model, all that business is there. Cybersecurity is pretty much in that state where software development was in the early 90s, where it's not that we are not considering cybersecurity. It's not that we don't implement crypto or we don't implement authentication, we do it. But it is neither being done systematically, nor is it being documented, nor is it being comprehensively carried out. And that is one of the things which drove the R155 and R156 was the Cyber Resilience Act of the EU. You can see the timing of R155 came just before the Cyber Resilience Act. Actually, it was supposed to have been released in 22. It finally got enacted in 24. But that is the place where it says that you need to do risk-based cybersecurity management through the life cycle of the vehicle. These are the two most important characteristics of the CSMS that you need to do. So it is not that you do it only at design time. You have to continue to monitor it through the life of the system and modify it as required. And that is what this standard effectively gives you. This standard is also organized very similar to the way 12207 or your software development standards are organized. There is an overarching organizational level of processes that you need to put in place. And those processes are fundamentally in terms of policy, in terms of roles, responsibilities, and that kind of stuff. Training, making sure the right guy is doing the right job, which is pretty standard, and that is covered by clause 5. Then you have the next set, which is at project level. Again, very similar to the way you would do it in software development. Only thing is here, when you talk about a project, I'm not talking about the vehicle itself as the project. I'm talking about the cyber security of the vehicle as the project. So here, project refers to cyber security of the vehicle. I'm not talking about the enterprise either. That is a separate ball game altogether. In this, effectively, you worry about risk-based cybersecurity management. So apart from the basic project planning and responsibilities and figuring out the exact scope and timelines, you need to do two major things. One is you need to figure out what is the risk, right? By virtue of its architecture and its components, what is the cybersecurity risk that it offers? And towards that, you carry out a threat analysis and risk assessment. And the output of this threat analysis and risk assessment, I guess many of you are familiar with functional safety. So what you do in functional safety as a HARA is what you call a TARA here. And at the end of a HARA, what you get is an ASIL rating for every component. Here you don't get an ASIL rating, we call it a risk. When you get an ASIL rating for a component, or you figure out what is the severity of impact of damage in functional safety, you have certain mitigation measures. Like, for example, you say, okay, I will fit an airbag, I will make sure you have your seat belt and all that business. Unfortunately, we can't do it quite so simply by fitting airbags and seat belts. So we use cybersecurity controls to mitigate or plug these vulnerabilities, right? And you end up with a residual risk, which is very similar to the residual risk you do when you get functional safety. Once you have done this, you treated the risk, you either accept it or you reduce it, you go on to designing your cybersecurity controls. The other part which is essential, which again came from the Cyber Resilience Act, was it said that you have to have cybersecurity by design. The general trend is in industry, I'm not talking about the automobile industry, it's across the board. The only guys I would exempt possibly would be the aviation industry, with whom I've done a good deal of work. But you cannot plug in cybersecurity as an overlay after you have done the design. Firstly, that is not as effective, and secondly, it's a damn sight more expensive. So you have to have cybersecurity by design, and you need to include it and cater for it, both in terms of design and in terms of final cost. Cybersecurity comes at a cost, in the same way as functional safety came as a cost. At a cost, you have to be willing to change your mindset, not your mindset, to change the mindset of your higher management, especially the finance guys, to realize that cybersecurity costs money and you can't do anything about it. And this fundamentally is how the CSMS process has come. And SUMS is actually a subset of a CSMS. Clause 13.4 says updates. And then it remains very silent about it because it knows that there is a standard called 24089 which will handle it. So though they are two separate regulations, SUMS is actually a subset of CSMS, and that is basically the background of the standard and what kind of mindset you would have to have.
Thank you. Thanks, Sadashiv, for the elaborate response. And Asad, now, for these clauses that Sadashiv mentioned, now, it is imperative that there has to be a business rationale to every solution that is being deployed. Not all of that that is mentioned in all of these clauses can be implemented in one go. There is no magic wand, nor there is unlimited budget. So from the technology point of view, because ultimately it is deploying some sort of technology somewhere. So can you tell us what's going on in secure things and what is new that's coming in these years, what has come already in the last year?
Yeah, thank you, Sadashiv, and thank you, Khushwant. Technology is really important before going any cybersecurity solutions. So, as Sadashiv said very well, threat analysis and risk assessment. That is important because every ECUs in a vehicles is not the same behavior. And nowadays, if you see like a software defined vehicle, multiple issues emerging into the one issues with the different technology. Let's say for an example, earlier we are using 100 issue, 200 issues in a car. So those hardware is isolated already. So risk was less. Now I mean to say like multiple hardware is emerging earlier like it was a virtualization. So hypervisor you can say. So hypervisor once came, then you can say like, okay, still it is a hardware isolation with little bit of cyber securities, loopholes. And nowadays, now containerization are coming because like, let's say for an example, you have a non-safety safety component like IVI and telematics and others issues. Wherever like you can have not to spend any money like on hardware, just keep one SoCs, one microcontroller, and then you can handle multiple issues in one with the help of, you can say like containerization. So once like we are moving with the software defined vehicle with the introducing a lot of LOC, line of code, absolutely a cyber security's risk is going to be increased. So this is from where we'll get. So you have to perform Tara, and from Tara we'll get this all you can say like gap into your like whatever vehicle architecture you are giving for you. So one is like world trend is moving in automotive complete design shift and technology adopting in the same time. So I mean like a cyber security is in secure things has adopted multiple technology. So I am especially like heading engineering team for vehicle cybersecurity solution. So cybersecurity is not a new. I mean like whoever like a system engineers here, I mean to say like it is not so much different than whatever system engineering do. So you should understand the system in deep and understanding the architecture, and absolutely like coding is my favorite. So I will say like if you don't know the coding, then I don't think so like you will understand real meaning of what is a solution you are giving. So I am at that level I'm trying to build our cyber security's hands-on managers, hands-on architect, hands-on developer. Absolutely yes. So that type of we are adopting the technology to understand a deep level. So here AI is coming, right? I mean like AI, everyone is AI is doing a lot of advertisement, but it is a true as well. I mean like AI is important and we are adopted very well. But adaptation is not just simple where AI adopt like anywhere. So what we did like, okay, a lot of things are there like which can we do done by the like a rules based something. Let's say for an example, some I mean like you can do a better in a functional way, not required like you can say like machine learning. So we have very well way gone to the system, and then we have developed our, let's say for an example, we have IDS, intrusion detection and prevention system, IDPS. So that work on multiple sensor. We have to understand software sensor where I have to put. Finally, your things is going from kernel, bootloader, right? So we have taken from kernel level what we can do at a packet level and system level so that we can analyze better to find out like intrusion and finally give the solution on a spot, right? Take the action in a spot. So we have like not only one, we can see like a Wi-Fi, Bluetooth, cellular host means like you can say like a QNX, FreeRTOS, and plus Android and Linux. These are the Linux means like I will say like automotive grade Linux, and Linux RT used for wherever real time you need like a cluster and all, right? So those areas we have gone through and then develop our IDPS in multiple like everything like a GPS also we have. So we have covered all like from hardware till like application level with the adaptation of whatever technology coming in the ground level. That is a one, and that is a like IDPS is a one like where is important, but like it is not limited to that at the rule based only. We have a machine learning completely like about your data, about your vehicle architecture, your ECU architecture, and then we are learning for 2 months for your data, and then like whatever model we are deploying into your like vehicle. So I mean, like, we'll maybe discuss some other time because it is a lot to go in detail, and normally I will not speak much. And plus, you can see, like, apart from this, not like ideas, we have like a system level, let's say, trusted execution environment. And secure boot, like everyone has a very traditional way, whatever going on, but we have a very different way where we measure KPI for your hardware within you can say like a reverse view camera or whatever, like a 2 second, yeah, whatever you have. Every KPI we meet with the very well performance, and wherever possible, like wherever needed, not possible, wherever needed, we'll put the machine learning and deep learning as well. So if you'll see like in ADAS, we have multiple solution. You can say like blinding attack. That is, we have very well way like image we are doing, and then in that, like we have a multiple, you can say like our patent technology and multiple solution on the base, and plus like adversarial attack might be you knowing. So that very latest technology, like whatever possible in going forward, level 2 and level 3 driving, once we will reach, our like a software stack, already we are providing the solution in that, so that like you can have the solution no, whenever needed, you can turn on. Even that, like long story short, I can say like we are providing currently whatever cryptography in the market available, right? That is stacked by anyway will have. But we are giving extra, you can say, some higher computing, like whenever you need like computing, like wherever like anyone can attack on your vehicle. So we have giving the extra cybersecurity stack wherever you can, like you can have like no, anytime you can turn on those algorithms. It is not like, okay, you are bound to have only one algorithm. So in a future also you can have. So we are taking care from secure things from hardware to till application level, every securities. Yeah, thank you very much.
So, summarizing, this is the introduction of the security stacks that will sit on the devices, and that includes hardware level security implementations. There are application layer, network, kernel, and middleware, and the intrusion detection for Linux, Android, and RTOS environments. So that's one that covers by and large the clause 9 outcomes, and this is mainly clause 10 implementation by and large. And then to back up all of this entire portfolio of the on the devices protection, there is also this threat intelligence platform that we introduced last year. So in conjunction with our existing threat intelligence platform and some additional features that we have added over the period of time, it makes a complete cybersecurity solution to meet all the standards or the regulatory requirements, from the device security to long-term vulnerability management. So since time is short, I will quickly move and conclude. So Secure Things overall is offering services for regulatory compliance, regulatory consultancy engineering, but then the middle part, the software stacks entirely, and the managed services for the Vehicle Security Operations Center. This is the need for introducing technology for meeting cybersecurity regulations, and nonetheless, we introduce our partner ecosystem. This you have seen in the previous session also. So this is an introduction of our partner ecosystem, which will first leverage our product competencies, secure devices, secure stacks, and the threat intelligence platform, and also the secure telematics or the connectivity gateway. That's in the red color, as you can see. And then the partners are welcome to join us. We have by and large covered the entire technology ecosystem, but we are even more open to explore more and more partners. So that's about it from Secure Things. Thank you, and I hope you had a great session.
Check. Yes, thank you so much. I request you to stand for the group photo. Okay. So moving on to the very next